Was there any on the preparation you guys wanted to go over?
I had one question that I circled. It's actually on the homework assignment. Did you guys look at the homework assignment part yet?
Yep.
Yeah.
Number 16 was hard for me. Oh, because when I put it in the applet, it gives like a number 2.0312E or whatever.
Mm-hmm.
Oh yeah.
So
yeah, the
when
one
you
with the little like blah 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 little E up in the corner.
E -4. Yeah.
Yeah.
So when it has the E -4, it means that you have to move the decimal point to the left 4 spaces. So it goes in front of the 2, and then three more spaces. So there's 3 zeros in front of that 2. That's how you interpret that.
Thank you.
Sure.
I don't think that was told in any video, because I'm looking at it. I'm like, I
don't think it was.
You told me that it was up there.
Yeah, it was in the video. I remember hearing it. I don't. I think it was. I think it was the one where he was going over the PowerPoint, or it was in the reading. But I remember it was.
I think he mentioned it in the video briefly, but I know that they did explain it to me in a previous math class that I had, so.
That's cool. That's a good thing to know, because I looked over at the answer and I'm like, I know my answer is right. Regardless of what you're saying, mine is right.
Right. So yeah, when it has that E negative, whatever the number is, and you move the decimal point to the left that many spaces.
So
I guess
it's 5.
Such a low number that they do it that way for some reason, but it's confusing.
Yeah.
If you just know to move the decimal point over that many spaces, then you're okay.
Okay, that sounds good. Thank you.
Sure.
I think that was the only thing that I had a question on in the other part. How about you guys?
Yeah.
I was good.
You're good? I liked the attachment he put to the question board. Did you guys look at that about the central limit theory?
Yeah.
That was good. That was a good one.
And I saved it.
Yeah, I know. I'm like, that's going in my notes.
I'm like, why couldn't that have been in the reading material? Because that was better explained.
It was, yeah. I kind of wonder, though, if we would have seen that attachment first, if it would have been equally as confusing, if we had to work through all of the other stuff to appreciate it. I don't know. Anyway, it's all good, right?
Yeah.
All right, let's go. So have you guys done the group work yet?
No.
No, not yet.
Okay. I have to get it back in my mind from the day before. So I've worked through some of them, but not all of them.
Okay.
Cool.
So should we do 3?
Yeah.
Yep. So the applet and 1.358.
Have to.
So when we do it, it should shade on the bottom portion and the top portion, but not in the middle portion, right?
Yeah.
Yeah.
Okay. And round to 3 decimal
So
places.
1.7.
0.175.
5.
Yeah. 0.175.
Yeah.
Do I need to hit a 0 in front of it?
I always do with mine, but I don't know if that'll
Oh, do you?
not, or
I haven't been putting them in mine, but I don't know. I don't know what I missed yet. Remember?
That's right. I don't know. To me, they have it like in the example with a 0 point and then the number, so that's just how I do it.
Yeah, that's probably a good habit.
Yeah.
All right, so 2.
Chris.
2.
Oh, 4, sorry. I can't get number 2 right. Can you help me?
2 is false.
Always mark false, especially for you, Nicole. Always.
Always false, you know? 2 is the 4. I like that. Me and my friends were having this discussion about the speed limits and what they really meant in California. It was pretty much
yeah?
like that. 65 is the new 80, because no one goes 65, everyone goes 80. But when it goes on to 55, 55 is really 65, which is really 80. But then when construction zones are 45, 45 is really 55, which is really 65, which is really 80.
And see, around here, you feel like you're going fast if you're going 40, because there's so much traffic that you never go faster than 40. Like we went out on a highway once and we got up to 55 or 60 and everyone was like, "Whoa, we're gonna die." It's weird.
Okay, so 4. That's a really lot of reading right there.
Yeah, it is.
My brain is.
All right. Well, do you want me to read it aloud?
Yeah, because my brain's.
I know I keep yawning myself. I'm like, whoa, the bed is calling my name.
Mm-hmm.
Number 4 says, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, than was observed in this sample. And note says, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive direction.
Wow.
Okay.
That was a lot of.
So if you're still awake, go ahead and work on that. Huh?
Oh, goodness.
Please be no questions like that on the test. This is.
So we still have to just find z-scores, right?
So it's.
Right, so you have to find the z-score. So you would do 177.6 minus 185 divided by 26.7 divided by the square root of 48.
Okay, that's what I was thinking.
You just got to plug in the right numbers in the right spots. Which can sometimes be more tricky than actually reading the problem.
Yeah.
Which was no easy task.
No. Well, sometimes it's easier. Like, you know it's not going to be 48 minus 185, so it's got to go at the bottom. So the 177.6 has got to go at the top. So sometimes it's just a common sense thing.
7.4. Negative 7.4. Negative 7.4.
So I got negative 1.9201. So negative 1.920. Is that right?
That's what I got.
All right.
I entered it all right. 1.920. So.
What did you guys say that you got negative 1.920?
Yeah.
Yeah.
So
Is that what yours says?
Yes.
That's what we put in?
Yes.
Right. Not that one.
So,
And we're due.
So we're still looking at below the red line and above the red line and nothing in the middle, and then we just plug this into the z-score.
Oh, on the applet.
Yeah.
Yeah.
Okay.
And I've got 0.0549,
Yeah.
and they want it rounded to
9
3.
round to, yeah, 0.055. That's what I got also.
0.055.
Yep.
0.0. Oh, yeah. It's like, where are you getting your other 0? Sorry.
In front of the point.
That'll help. All right.
Too many numbers.
It is. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
The one where it would be the square root, wouldn't it?
Which of the following will have a smaller standard deviation?
The standard deviation that's the square root is smaller than the other standard deviation. Would it be B?
Was I taught this?
This sounds really kind of...
When sample size increases, the standard deviation of the sample
I'm thinking it's B.
That's my gut, but...
That's what I'm thinking too, but I'm not sure on this one.
I like proof of like something that they've said, and I don't remember, you know, them saying the distribution of the sample mean is smaller.
Let me see something.
The only thing that I can think that kind of relates to that we've done is on the homework, the very last question. When it says compare the z-score and probability from question 13 and 14 to the z-score and probability from questions 15 and 16.
Yeah.
It says what happens when the probability when a z-score is further away from the center of normal distribution, and why is that happening? And the answer says probability shrinks as the z-score moves further away from the mean. But, I mean, that doesn't really say anything about standard deviation, but...
I remember reading somewhere that it was saying the standard deviation of the sample means is always less than the population standard deviation.
Yeah, by like
I thought
half.
I remember that too, but...
Is that what this is kind of similar to, or...?
So if 9's a small sample, so it's not going to bring that in any closer, so it's a smaller deviation, right? So that law of large numbers isn't going to work because it's only 9. Is that right?
Right.
If 9 observations are randomly drawn from a population, the distribution of the individual observation.
I really want to say it's B.
I don't think the individual observations are going to change, right?
Right.
No.
The only thing that would change is a sample.
Yeah.
Right.
So do we have enough information to make that true?
That's a good question.
Yeah.
Well, I really want to say B, but
Yeah. It's either B or C.
Right. Well, when we're done, I'll submit first, and I'll tell you if we got it right or not.
Let's go. I would go for B. Not because I have a good understanding of what it is they're even asking for on that one.
I don't know. I'm thinking it's B. That's what my gut's telling me, and I'm just gonna go with that. So.
Sounds good. All right.
But,
Which
yeah,
of the following results?
if you want to be guinea pig and submit it first, you can do that too.
Which of the following results implies that the spread in X decreases as the sample size increases? So 6, I think, is law of large numbers.
I was thinking it was the central limit theorem.
Were you?
Yeah, because weren't we saying last week that the central limit theorem had to do with spread? And the law of large numbers was accuracy? Well, that's kind of accuracy too.
Yeah. I was thinking that central limit is more of the shape.
As we all pull up our information from the last one, right?
Good idea. As the sample size increases, the standard deviation of the sample mean will get smaller. Yep, you were right. It is the law of large numbers.
Does that fit?
Yeah, it says here the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed. That's it.
So
The law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller.
Okay. So does that mean then that the only thing the central limit theory is talking about is a normal curve?
Yeah.
Because some of the
sound like, because it says that's it after that.
Yeah.
So
I like that point.
that if the sample size is large, the sample mean will be approximately normally distributed.
Mm-hmm.
So yeah. I don't know why are those two so confusing. I
don't know.
Switch up and stuff.
Because they're the same, but they're not.
Yeah, they're like
and they're
similar,
used
but
differently.
not quite.
Right. All right.
So 6 is law of large numbers.
I think so, and I just think like you can't get accurate unless you're bringing in all those standard deviations. Is kind of how I think of it.
Yeah.
So we've got normal with a mean of 150.8 and deviation of 8.8.
Okay.
So then this would be the 160 minus the 150.8. 8 over 8.8 divided by, yeah.
I think that's all, just divided by 8.8.
Yeah, because we're not
there's
dealing with various samples, we're dealing with an individual score.
Just one. Yeah.
Right.
So 1.045. 3 decimal.
Yep, and that's what I got.
Okay.
1.045.
Yeah.
Yep.
So what is the probability that a randomly selected student will score above 160?
So then we put that in.
So you take the 1.045 and plug it into the normal probability applet.
And just the one side, right?
We want a greater than?
So it'll be on the right side.
So 0.1480.
1.0. What are we putting in? 1.045.
Which shows 0.1480.
0.14. Right.
Which would be 0.148 on the entrance since we're rounding to 3.
Thank you.
Don't put the
That
zero!
makes me so mad. That makes me so mad when I miss it on those kind of things. And I think on lesson 5 I missed 2 of them because I didn't round right.
Oh my
I'm
goodness.
so mad. That's when I want an actual teacher grading my work, not a computer.
Nope.
Okay, this one I think is confused me, so I'll need help. Just to see if I'm doing it right.
What is the z-score corresponding to the sample mean of these students' scores? So first we've got to find the mean of those scores.
Okay, that's what I thought.
Plus
Yeah.
175, plus 163, plus 149, plus 153. It's 800 divided by 5.
160.
160.
160. Yep.
So it's going to be the same as the one above because it's 160. So minus the 150.8 divided by 8.8, which gave us the 1.045.
Yeah.
That's what I thought, but then I think when I looked at it again, I think we have to do it divided by the sample size
Oh,
because there's a sample of 5.
There you
divided by the
go.
square root of 5.
That's what I think and what I'm asking at the same time.
Yeah, that makes sense.
I'm like,
Yes.
they aren't gonna want to ask me the same question right in a row.
Right, I
That
know.
would
At
be-
first I was like, that's kind of weird. That's the same question almost. But yes, I think.
Yeah.
Okay.
So 160
Over
is 150.
square root is 8.8 divided by 6. 8.9.
0.3377.
9.2 divided by
2.338.
Yeah. So 8. Yeah.
3.
3 decimal places. Yeah.
2.338. So then we plug that into the z-score.
Yep. And make sure that to the right of the line is highlighted since we want greater than.
So
Yeah.
0.0097.
2 sorry.
0.0097 you said?
7.
Yeah.
Yeah.
So since we're rounding, oh, this is 4 decimal places. Okay.
Yeah.
That's why it's always good to read.
Oh, and reread and circle.
And reread again.
0.010.
What are you talking about?
I said, how would you round that? 0.10? Or
Um,
010?
the 7 would round the 9 to a 10, so it'd be .010
Okay.
if you were doing 3. But luckily we don't have to. All right, 11. Mean is 3.5.
So it
And
okay. So then it would be approximately normal. So 81 students for the sample.
Yeah. Right.
approximately normal.
That's kind of what we are. We're approximately normal. Not all the way, just approximately.
I like that.
So do I. So do I.
So,
Little tell my kids.
so since my name is Abby for abnormal, I'm approximately normal.
I like it.
Yeah. Abby,
It's a meme.
someone?
So then, for this
This is the one that threw me. This was. Don't they usually give us the mean of the distribution?
Yeah.
So we have to rework a formula.
No, the mean is 3.5 and the deviation is 0.7.
Okay. The mean of the
Yes,
distribution.
For all possible samples of size 81 that could be drawn from the parent population. So isn't the sample mean the same as the mean? So wouldn't it be 3.5?
Yeah.
Okay. Yeah, I was making it harder on myself. I looked at that and I'm like,
tricky.
I know. That's my problem.
I hate that. I feel like all these are like trying to say it in a way that's going to trip you up so you get it wrong on purpose.
Yeah, it's like being haunted by bad goblins. They're out to get you and for no reason.
Right, I know. And we're only a quarter of the way through this stuff.
But it's a quarter and that counts.
So the answer is 3.5?
Yes.
I don't know. I was not paying attention. What is the mean? Sorry.
Because it's a large sample, it will be approximately normal, which means that the mean will be approximately the same mean as the population, which was 3.5.
So that's all they want. That is all they want. And I have like this whole, like I tried to rework a formula. I'm like, what? That's why they put me in groups.
Yeah, really, I know. We can help each other when we're, just lost.
So,
yeah.
So then for 13,
what is the standard deviation of the sampling distribution of the random variable x?
it wouldn't be 0.7, would it?
No.
I think you have to do it over the square root of 81.
So 0.7 divided by the square root of 81.
Yeah. The standard deviation of the sample is the standard deviation of the population divided by the square root of the sample, which is 81.
Right.
So 0.7 divided by 9.
Sure. You do it easy. I'm like, oh no, I've got to do it the hard way.
The square root of 81 is 9. I know that.
I don't want any of the keys on my calculator to feel ignored.
Oh, okay. I'm sorry.
That's okay. It's not offended.
So it would be 0.078.
Yeah.
Yep. That's what I got.
Less than 3.3.
problem?
3.3 minus 3.5 divided by 0.7 over the square root of 81.
Yeah, or you can just use divide by 0.078 because we figured that out in the previous one.
Okay, but yeah, that is what the...
Yeah.
-0.2 over...
Hey, Britton.
Hi.
How are you?
Good. How are you?
Hanging in there.
So it would be negative 2.571.
Negative 2.5. How many decimal places did you carry it out to?
I just stopped at the 1.
Okay.
Okay, well, never mind.
So you did 3.3 minus 3.5 divided by, did you do 0.078 or did you do more?
I did the 0.0777, yeah. So if you round it, then it would be, doing it like that, I got 2.571, but doing it by the other one, I got negative 2.564.
Yeah, that's what I got.
So you're going to call the z-score negative 2.56? Or no?
Yeah, negative 2.564.
What?
And when you plug that into the z-score, I got 0.005.
We're just doing less than?
What was that?
Just the less than part? Is that all we want? What are we trying to do?
Just the very left.
I can't get rid of my right part.
Did you click on it?
Go away.
What'd you get?
Yeah, it stays blue.
So what's the answer?
0.005.
That's what I got earlier, but I don't know why
It's still
can't make my blue part work. It's driving me crazy.
Try exiting out of the applet and reopening it. Maybe it just got stuck or something.
Yeah, because it won't let me.
What number are you guys on?
Be great.
14.
So for the last one, we click the middle and the left.
The middle and the right.
Yeah, that's what I meant.
Unclick the left. Yeah.
Yeah, yeah. So then 0.9951 ish.
Yeah, but you round so you get 0.995.
Yeah. 0.995. Okay.
Okay, what is the probability? Will be greater than that? Didn't you get the same probability?
Mm-hmm.
On 15.
No, because you do the both.
Yeah, you take off the very left one and you check the middle and the right.
Oh. Sorry.
That's okay.
Let's see. Probability will be greater than 3.8. Now I'm with you.
Okay.
Okay.
And remember, the total probability has to equal 1. So if you add 14 and 15 together, they should equal 1.
Yep. Very good. Thank you.
Sure. All right. I'm submitting, so let's see if we got them all right. Yay! They're all right.
Hey, good work.
Okay, let's see if I entered them all right to get them all right. Yay!
That's the second part, isn't it? Once we have the right answers to getting the right answers. It's crazy. Do you need some help on the other ones, Britton?
No, I can probably get it.
Are you sure?
Yeah. Sorry, I didn't get the email until like 5 minutes ago, so.
Oh no.
Oh, bummer. The invite didn't come through for Google? Oh, that's weird. I guess weird but not surprising, right? It's
Yeah.
electronic.
Yeah, that's weird that you would just get it now.
Yeah.
Well, I have to enter mine in the computer anyway. I'm going to try and pull up another screen so I can put my answers in. But if you want to hang out, we can compare notes if you want, Britton.
That's okay. I can just get it all done.
Okay.
I have lots of
Sounds
stuff to do tonight, so maybe I'll do it tomorrow.
Oh, okay.
Well, and then once I post the link, then you can watch it again.
Oh, that's true.
Yeah.
That's a good way to do
What I
it.
do before every test.
That's a good idea.
Oh, I didn't even think of using that.
Well,
That's a good idea. A good way to review.
Because there's no way I'm taking the homework quiz tonight, because I'm tired. Just like,
Yeah.
Every night. So then right before I take it, I watch it again, so it's like I'm in the group again.
That's smart.
That's a really good idea.
Yep.
Okay, I'm going to stop this.
One parting picture for him. Don't you love to watch him back and see what you look like?